So the best strategy in solving compound inequalities is to always separate your inequalities, split and solve them separately. Then graph those two solutions together on the same number line. So let's do some examples. All right, there's a compound inequality, and you know it's a compound inequality because how many alligators or inequality symbols do you see in there? Two. There's the less than over here, and then the other one's less than equal to. All right, so there's two problems in one here. The first problem is this half. The next problem is the middle again with the other half. So we're going to draw boxes to split them up. All right, there's the first inequality inside there. The other one uses the middle again. So x plus 4. X plus 4 is less than equal to 4. So there's two problems in one. What on the left side? What's the first step? Subtract 4. Subtract 4 from both sides. That will leave us with negative 6 is less than equal to, less than x. Now that's not going to be very, very easy to graph. Let's turn that around to make it nice and graph friendly. So again, flip the x and the negative 6 and make sure the inequality is still eating the same thing. It's got to be eating the x in that direction here. Again, these are equivalent statements. They mean the same thing. This bottom one's easier to graph though. All right, now let's go to this next one here. What's the first step here? Subtract 4 again, huh? So subtract 4, subtract 4. We're left with x equals, less than equal to what? 0. Is it okay to have 0 in there? Yeah, don't freak out. It's okay. So there's our two solutions, and now let's graph them together on a number line. All right, now we have our number line. What's the leftmost point, our critical value? Negative 6. Open or close here at negative 6? Open. We're not including negative 6 in our answers. In which direction is this graph going to go? Right. Greater numbers are to the right. All right, the next one here, the blue one, x is less than or equal to 0. We're going to start where? At 0. And what kind of dot there? Close. Fill it in. We're including 0. And which way is left? Or sorry, less than? It's to the left. They come together. All right, so when we see this in the graph, this is when we say it's an and statement. You go, oh, okay, here's my answers. I got x is greater than negative 6, and I got x is less than 0, equal to 0. Those are your two answers. All right, here is another example of a compound inequality, the OR compound inequality. What gives it away is the word or in between. Okay, you have two inequalities with the word or in between, so you know you're going to be dealing with these or graphs in a minute here. So to solve these again separately like the last one, take one problem at a time. Go ahead and solve this problem. What's our only step here? Add 4 to both sides. Let me go ahead and do that. We're going to add 4 to both sides. That leaves us with x is what? Less than or equal to 7. Okay. The other one, what's our step to do over there? Divide by 2 to get rid of that 2. So our x will be what? 9. Greater than 9. Greater than 9. Don't say it's an or yet until you graph it. So we'll make a number line down below. Let me change that color to the right color. Did it? Oh, it did work. No way. All right, so what's our leftmost points in our solution here? 7. 7. That's going to be the most left on our number line. So let's start maybe at 5, 6, 7, 8, 9, 10. All right, so our 7 is going to be a closed circle. And what direction is that going to go? To the left. Again, it's closed because we are equal to 7. We're including 7. 9, we're not going to include 9. Not equal to 9. Open circle going which way? Right. To the right. And then again, we see these graphs going opposite ways of each other. These are going to be OR statements. So there's our answer in inequality form, and here's the graph to match it. All right, number one, we're going to subtract 1 from both sides, and then we're going to have 3x is less than 3. Divide by our 3 to get 1 for that first one there. Over here, we're going to add 5 to both sides, so 2x is greater than what? 12. 7 plus 5 is 12. All right, divide by 2. What's our answer here?
6.
X is greater than 6. We're not sure what it looks like until we graph it. So let's go ahead and graph it and see what it looks like. What's my leftmost value? 1. So here's 0. Here's 1, 2, 3, 4, 5, 6, and 7. Let's go by 2s. So at 1, I am open or closed? Open, not equal to 1, and going to the left. Less is left. At 6, we are open, going to the right. So now we see it's an or statement. So we're going to write or in between our two answers. Okay. All right, now. All right, don't forget to split up our two different inequalities that are inside this compound inequality. The best thing to do is use a box. So we're going to box up this one and solve this separately on the side over here. So -2 is less than -2 minus x. So the first thing to do is on this one is add our 2 to both sides. Add 2 to both sides. That leaves us with a 0 over here. That's less than or equal, or not equal to, just less than x. Negative x, actually. And we have to divide by -1. It's kind of tricky. Divide by -1 to get rid of the negative. And remember, even though it's going to be 0, we still have to flip the inequality around. Okay, it was less than, now it becomes a greater than. So that would be our value right there for x. All right, let's do the next one. Box up our -2 minus x is less than 1. Solve this separately as well. So we'd have -2 minus x less than 1. First step here is to add 2 to both sides. We're going to add 2. So -x is now less than 3. And again, we have the -x. To get rid of it, we divide by -1. And then we have to flip the inequality because we divide by a negative. So now x will be greater than -3. Now let's graph this on the number line and see what kind of statement we're going to get. Let me make my number line here. Let's make it on the side right here. Make a small one. Running out of room. So there's our number line. Our leftmost value, our smallest solution point here is -3. So we're going to put that down. So we'll have -4, -3, -2, -1, 0, and 1. So at -3, we are an open circle here, and it's going to the right, For the other solution that we got, it was greater than 0, or I'm sorry, less than 0. We didn't write it the better way. Remember, let's put this the equivalent way with the x first, and still eating the same value there, 0. This helps us, this version here helps us to graph on the number line. So we go to 0, and we put an open circle, because we're not equal to 0, and this is all less than 0, so it's going to go to the left, and they come together. So we have an and for our answer here, so it's going to be x is less than 0, and x is greater than -3. Let me box this up. There it is. And there's our number line answer. May the math be with you.